Welcome back. So, what we did in the previous video is we sketched the graph of y equals sine of x, and what did we get? We got something that starts at 0, 0, makes it up to 1 at pi over 2, back down to 0 at pi, back down to negative 1 at pi plus pi over 2, so 3 pi over 2, 0 at 2 pi, and then it repeats. Your graph will look better than mine because, well, that looks like garbage. Let's try to use that graph to figure out the graph of cosine of x. Now, what one could do is you could do the exact same thing as we did in the previous video for cosine. Or you could plot some points on the graph of cosine, use periodicity to finish it up. But let's remember some identities we have that tell us the graph, that will tell us cosine in terms of sine. So let's remember what we got in the previous lecture. We saw that the sine of, well, it was theta then, but here it'll be x because I want x to be an independent variable. X plus 2 pi k is the same as the sine of x. So that won't be useful if we want to understand cosine. We know that the sine of let's see, I think the first thing we did was pi minus x. That was the same as the sine of x. That's not useful. Sine of pi plus x, same as the sine of x, not useful. Sine of pi over 2 minus x is the same thing as the cosine of x. That could be useful, except it has like an annoying negative sign there, so that means I would need to, I guess, shift left by pi over 2 and then reflect over the y-axis. So I won't use that. Still, I'll use the final identity that we got last time, which says that the sine of pi over 2 plus x is the same as the cosine of x. There's the one that I'll actually use. So I know that cosine of x is the same thing as sine of x plus pi over 2. What does that mean about the graph? That says that the graph of cosine of x, alright, that should be the exact same as the graph of sine of x, but it'll be shifted left by pi over 2. So the graph of cosine of x is the same as the graph of sine of x shifted left by pi over 2. So I'll do that in this space, and then I'll copy it down here. So let's take this graph and shift it left by pi over 2. So remember, this point right here is at pi over 2 comma 1. Shift that left, it'll become 0 comma 1. This point right here is at pi comma 0. It will now become pi over 2 comma 0. This point right here at 3 pi over 2 comma negative 1 will become this point, and maybe you notice a pattern. There we'll see a graph that looks something like this. So copying that down exactly. I don't know how to do that in any sneaky way. So let's see. I don't like how that looked. So it starts at 0, 1, makes it to pi comma negative 1, then back up to 2 pi comma 1, and then, well, I know it's going to repeat, so from here I can go on just autopilot, right? Cool. So let's ask the same questions. What's the maximum value? Well, this graph is a shift of the graph of sine, so the maximum value should be the exact same as the maximum value for sine, which was 1. And the locations of the maximum values, well, we can read them off. Looks like there's a maximum value at 0, maximum value at 2 pi, maximum value at 4 pi, maximum value at negative 2 pi. It looks like every even multiple of pi. So the max value is y equals 1. Achieved. Spelling is very hard. I'm going to leave that misspelling right there, though. Achieved at x equal to negative 2 pi, 0, 2 pi, 4 pi, dot dot dot, in general, at x equal to any even multiple of pi. So anything that looks like 2k times pi. 2k being any even number, pi, well, being pi. So any even number times pi. What is the minimum value? Well, the minimum value should be the same as the minimum value for sine. So the min value is y equals negative 1, and it is achieved at x equal to, well, let's start listing them by looking at the graph above, at negative pi, at 3 pi, at 5 pi, 7 pi, 9 pi, and so on, at x equal to, writing them down, negative pi, 3 pi, 5 pi, and so on. It looks like in general, at x equal to any odd number times pi. Well, an odd number is a number that looks like 2k plus 1 times pi, where k is an integer. Is cosine even or odd? Well, take a look at that. If I took that graph and reflected it over the y-axis, do I get the same graph again? Sure do. So it should be even. And in fact, we already knew it was, because according to what we did last time, the cosine of negative, well, we said theta, but I'll say x, it doesn't matter what you call your variable, is the same thing as the cosine of x. So it should be even. Where is it increasing? Well, let's just trace them out. It looks like it's increasing from negative pi to 0. From pi to 2 pi. From 3 pi to 4 pi. And so on. It should be decreasing everywhere that it's not increasing. So it's decreasing from negative 2 pi to negative pi, negative 2 pi to negative pi, from 0 to pi, from 2 pi to 3 pi, from 4 pi to 5 pi, and so on. Where are the turning points? Well, we see them. Looks like it turns around at negative 2 pi, at negative pi, at 0, at pi, at 2 pi, at 3 pi, at 4 pi. So writing those out, so at x equals negative 2 pi, negative pi, 0, pi, 2 pi, and so on. And we can even describe that pattern very explicitly. That's just anything that's a multiple of pi. The turning point is at x equal to anything that looks like pi k, any multiple of pi. Groovy. So, that finishes just my discussion of cosine. We'll come back in just a moment.